Thank you for joining me once again on the second order differential equations. This is part 2 of this topic. I've already done a previous video for this topic. There is a first video called solution types for second order differential equation. This is the first video you need to watch to understand how to generate the solution types for second order differential equation. Then you can watch second order differential equation part 1, and then this is part 2. So in this example, we have the square y dx square minus 5 dy dx plus 6y equals 2 sine 4x. This will be a little complex, so I will need you to cooperate with me, and I hope by the end of this video you would get the understanding you are looking for. So in my first video under solution types, I explained that when we see something like this, it's a second order because the derivative term here is second differentiation, and this part of the equation, which is the left hand side, is called the complementary part of the equation, and this side is called the particular integral. So the complementary function plus the particular integral will give us the general solution for the second order differential equation. So before we can work on the complementary function, which is the one on our left side, we need to assume that this side is 0. So we equate the complementary function to what? To 0. We need to find the auxiliary equation. We say we work only on this side and equate this side to 0. So we have m squared minus 5m plus 6 equals 0. Now we represent the derivative terms with the variable m. Since the derivative is second order, you square this side. This is derivative, you make it m, you pick the coefficients of y and you equate the function to 0 to solve for the complementary function. So this has become a quadratic equation and it is called the auxiliary equation. So to solve this, I just need to factorize this. This is going to give me m squared minus 2m minus 3m plus 6 equals 0. So when I factorize m squared minus 2m, I'm getting m outside, m minus 2 minus this 3 outside, m minus 2 equals 0. So when I multiply this, I generate this, and I multiply this, I'll get that. So now we pick one of this in the bracket, having m minus 2, and we pick m minus 3. M minus 3 equals 0. So we say that m minus 2 equals 0. So therefore, m1 equals 2. We bring this to this side, then m minus 3 equals 0. Therefore, m2 equals 3. Now, if you have already gone over the solution type video, you should note that whenever the root of the equation or the auxiliary equation are two real values but of different roots, these are two values, they are two different values, but they are what? They are real. Then the final solution for that function would be y equals a exponential function m1x plus b exponential function m2x. I just wrote down the formula so that I can input the values. There's no need for you to do that. You can just move straight forward. So this becomes y equals ae 2x plus be 3x. So this is our final solution. This is what you are supposed to write. You may be thinking why the final solution will be of this form. You need to watch solution types for second order differential equation on this same channel to understand this. I may not go deeper here. So this is what we are generating. We generate a solution of this form if the roots of the auxiliary equation are real but of different values. Alright, so now this is the solution for the complementary part of the question. This is what we call the complementary function solution. So now we need to work a solution for the particular integral function here, f of x. So to do that, we look at the function f of x, and then we go back and assumed the particular integral solution for what? This f of x. So let's see what will happen. So before I talk about the particular integral solution, let's look at this. As a student, it is very important that you have gone through the particular integral solution, the way you should write the general solution for y in order to be able to calculate for the coefficients or the constant c, cd, cde, cd, cd, and c. Now, anytime the particular function, which is f of x, now I said in the beginning that this part of the function is called the f of x part of the function. It is f of x. And so if f of x is in this form, what will be the assumed particular integral? So you are supposed to know this in mind. If f of x is any of this form, if f of x is k, then we assume that for the particular integral, y will be equal to c. If f of x is kx, then we assume that y is equal to cx plus d. Remember that k is any number, which is k here is a constant. So if f of x here was supposed to be, let's say, 2, if only 2 was supposed to be here, then I will assume that the particular integral solution will be in the form y equals c. Then I'll calculate to find the value for c. If it is kx, this is what you get. If it is kx squared, this is what you get. So if it is kx squared, you write y equals cs squared plus dx plus e. You solve to look for the solution or to look for the possible values of c, d, and e, which are 3 separate variables you must work for. Then if f of x equals k sine x or k cos x, then we assume that y equals c cos x plus d sine x. Note, if f of x is equal to just one of this, you write y equals everything here. So if it is cos or sine, this is what you write, and you calculate for c and d. And if it is for sine and cos, then you write this. If it is e raised to the power kx, this is what you write. So when we look at the question we are solving, we were given this. F of x is this, so our assumed particular integral solution will be of this form. We are picking this, and we work for c and d. So we are now coming to assume that the particular integral solution will be of this form. So now we know the solution types and we know what to write. So since we have 2 sine 4x, which is equal to what we spoke of, this 2 was representing the k that we came across. So we assume that the particular integral solution, or look at what I have written here, for the particular integral, assume the general form of the right hand side, which is this, is, so we have already assumed, so we know what we are supposed to put here is y equals c cos. Now there is 4 here, so you also write the same, c cos 4x plus d sine 4x. So whatever number is here, that is what you repeat here. The same number is what you repeat. But for the constant k, there is no need for you to, you don't put it here. We will bring back this k, or we will work on this k when we finish and we are doing substitution. So when we are calculating for c and d, then this 2 here, which is the k, will come in. Now that we have been able to assume the particular integral part of the question, we need to differentiate. Now, since this is a second order differential equation, when we look at this, we now have the y term, which is equal to this. We now need to differentiate this function y to produce the second term dy dx, and then we differentiate the second time to produce the d square y dx, so that we can do the substitution. So now I'll differentiate this function. Note that if you want to differentiate something like this, when we differentiate cos, we are going to get minus sine. And then before you can do this differentiation, you need to know how to differentiate something like this. So first you differentiate what is here, 4x. When we differentiate 4x, we will get 4. It is x raised to the power 1 here. 1 times 4, 1 minus 1. So it will give us 4x raised to the power 0. X becomes what? 0. Anything to power 0 is 1. So we are getting 4. So you bring the 4 outside. Then you differentiate cos, you get minus sine, the same 4. So the minus will affect the 4. So now when I differentiate 4 cos 4x, I'm getting minus 4 sine 4x. So I'll write my dy dx, because I'm differentiating y with respect to x, will give me minus 4 sine 4x. And I said that differentiate 4x, you get 4. Bring it out. Differentiate cos, you get what? You get minus sine, and this is the minus. But I was supposed to bring my constant, so let me put this in bracket, multiply by c. I was not supposed to do it this way, but because I didn't write the c, that is why I brought it here. Plus, now when I differentiate sine, I'll get what? Cos. So I'll first differentiate this side, I'll get 4. So I'll get plus 4d cos 4x. So this is it. So let me rewrite this term again because of the error here. Now, we differentiate the function the second time because we have a second derivative here. So this will give me the square y all over the x squared equals. Now when I differentiate 4 here, 4x here, I'll get 4. 4 times this 4 will give me minus 16. So minus 16c. Then when you differentiate sine, you get cos. Cos, the same for x. Then when I differentiate cos here, I am getting negative sine 4x. But I'll first differentiate this 4x to get 4. So 4 will give me 16. But because of the negative sign, so I'm getting minus 16 sine 4x. So these are my solutions for the first derivative and the second derivative. So I will name this side equation 1. I'll name the first derivative equation 2. Then I'll name the third derivative equation 3. And we will use these equations to solve the work. So now these were the 3 equations that we generated, 1, 2, and 3. Now in our next step, we need to recall the original function given to us. The original equation was this. So we recall the equation and we substitute the equation 1, 2, 3 inside the main equation. So let's do that. So this is our original function, the main equation. So now we are putting in equation 1, 2, 3 here. So now we know d square y dx square is the same as this one. So we substitute it inside and we get minus 16 c cos 4x minus 16 d sine 4x. Now there is minus 5 here. I'm done with that. So I'll bring my minus 5 into bracket. Now this minus 5 is multiplying the first derivative dy dx, and dy dx is everything we have here. So now you put it inside. We have minus 4c sine 4x. Then we have plus 4d cos 4x, bracket close. Then we have plus 6. So plus 6y, where y is what? The first equation. So I'll put it inside c cos 4x plus d sine 4x and bracket close. So now this is what we have. Your next step is to expand minus 5 and expand 6. So we are getting minus 16c cos 4x, then minus 16d sine 4x. Then we have minus 5 times this will give us plus 20c sine 4x. This time this will give us minus 20d cos 4x. Now this time this will give us plus 6c cos 4x, and then this is giving us plus 6d sine 4x. So now this is what we have. In our next step, we are about to group like terms. We group all sine to one side and then all cos to the other side. So let's start by grouping the sine. So I'll pick minus 20. So this is giving me, let me pick 20 here. So we have 20 c sine 4x. Which one is the next one we should pick? Let's pick this one. So minus 16d sine 4x. Then the last one is this one, which is the sine here. So we pick plus 6d sine 4x. So not to confuse you, let me put everything here in one bracket. Plus, let's group for all cos. So first let me pick this one here. So I'm picking the c first. Minus 16c cos 4x. Then I'll pick this one. Minus 20d cos 4x. And the last one is plus 6c cos 4x, and this is it. So now when you look at this, we can subtract d and d. So we can add 6d to minus 16d, giving us minus 10d, and we can also add 6 and then 16c here, giving us what? Minus 10c cos 4x. So let's do that. So now we have 20c sine 4x. When we add this, we are getting minus 10d sine 4x, and then we can work on this one. Let's pick minus 20 first. Minus 20d cos 4x. Now add this one to this one, we are getting minus 10c cos 4x. So now we have c here, we have d here, we have sine, so we can factorize the sine out. So this is going to give us 20c minus 10d, all bracket sine 4x. Then I'll do the same thing here. So minus, I'm getting, so we have 20d plus 10c bracket close cos 4x. The reason why I made this positive and positive, so that when this negative multiply this, I'll get minus 20d, and when this one also multiply this, I'll get minus 10 what? C, which is still the same. So now I'll rewrite this. Let's not forget that whatever that we have here is equal to sine, is equal to 2 sine 4x, and everything that we have here that we have solved so far from this step, this step, this step up to this side belongs to this part. So I have to equate everything I have here to 2 sine 4x. So now I am getting 20c minus 10d sine 4x minus 10c plus 20d. I just want to write the c first before the d, cos 4x equal to our 2 sine 4x, 2 sine 4x. So now let me name this one equation star. It is very simple now for us to solve. The next thing we are coming to do is to compare what we call the coefficients of the sine here. The coefficients of sine 4x here is 20c minus 10d, and we compare it to the right side. What is the coefficients of sine 4x here? It is 2. So this means that 20c minus 10d equals 2. Then we can solve for what? C and d. Then we compare minus 10c plus 20d cos plus 20d with the right side. But when we look at this side, the right side, we don't have anything at the right side. So that means on the right hand side, cos, the coefficients of the cos, everything there is 0. So minus 10c plus 20d will be equal to what? 0. So now let's do that. Let's compare the coefficients here with the coefficients here. So now we are now using what we call the k, as I spoke of earlier. So we have 20c minus 10d equal to 2. And let's name this one equation A. And then minus into 10c plus 20d equals 0. Let's name this equation B. So like I explained earlier, the equation sign on the right hand side has no part for what? Cos. So it means that side is 0. So everything for the coefficients here equal to what? 0. Now these are two simultaneous equations. If I want to get rid of one of the variables here, I'll just pick the constant here and use it to multiply equation B. When I do that, I am going to get 20c here plus 40d, so that this 20c and this one will be the same. Then I can just cancel it out. Let's work on equation B. This is minus 10c minus 20d. I'm just using this negative to multiply through, equal to 0. And this is equation B. So multiply equation B by 2. So equation B, and multiply it by 2. So this is giving me, so now 2 times this 10 will give me minus 20c, and 2 times this will give me minus 40d equals 2 times 0 will give me 0. So let me name this one equation C. So now we consider equation A and equation C so that we can work on it. So this is 20c minus 10d giving us 2. And this was equation A. Then we have minus 20c minus 40d giving us 0. This is equation what? C. So I can add equation A and C so that I'll get rid of what? The C here, and I can work on D. So when I add equation A and C, like I've written here, what am I going to get? This side will be 0 and this will give me minus 50. So I'm getting minus 50D. C is 0, so there's no need for me to write it. Equal to 0 plus 2 will give me what? 2. So therefore, D equals 2 over minus 50. So this into this will give us 1. This into this will give us 25. I'm just doing that, there's no need. So therefore, D equals minus 1 out of 25. And this is the value for D. So I can substitute D into any of the original equation to produce the answer for C. So let's consider, consider equation A. So A is 20C minus 10D equals 2. So wherever I see D, I'll substitute this one. So we have 20C minus 10, and D is minus 1 over 25 equals 2. And so when I do this, I am getting 20C, this time this. Remember that this is a whole number, so it is over 1. So I'm getting plus 10 out of 25 equals 2. So now we can break this down with 5. This will give us, let's say, this is giving us 2 and this is giving us 5. So I'm getting 20C plus 2 out of 5 giving me 2. So from here, change the function to linear, multiply the whole function by 5 to make it, this is 5 times 20C plus 5 times 2 out of 5, then this will cancel this, equal to 2 times 5. So I'm getting, this is giving me 100C plus 2 equals to 10. So when we work this out, we are getting 100C equal to 10 minus 2. So 10 minus 2 give us 100C equal to 8. So therefore, C equals 8 over 100, which is giving us 2 over 25. So now this is the value of C. So these are the values of C and D. C was equal to this, D was equal to that. So now we move back to the original function and write our final solution. We have, this is the function, and the final solution will be the general solution, which is equal to the complementary function plus the particular integral function. So the complementary function, we got y equal to a e 2x plus b 3x. So now our general solution equals y general is equal to complementary function plus particular integral. So what was our complementary function? Our complementary function was, let's see, y equals, it gave us a e 2x plus b e 3x. So this was our complementary function, and then our general solution for particular integral was supposed to be in c cos 4s plus d sin 4s from equation 1. So now we know the value of c to be 2 over 25, and we know d to be negative 1 over 25. So now we are getting everything here plus 2 over 25 cos 4x minus, this is 1 over 25, 1 over 25 sine 4x. So that is what I have produced. D was 1 over 25, negative 1 over 25, that is there, and C was positive 2 over 25. So this is the final solution for your second order differential equation. You are told to differentiate this function. This is the final solution for the second order differential equation. The general equation was equal to y equals a e 2x plus b exponential function 3x plus 2 over 25 cos 4x minus 1 over 25 sine 4x. So you need to know your particular integral solutions. You need to know everything here so that whenever you have f of x, you can assume the particular integral solution or integral function to be able to know what you are solving, so that you can find the values of the constant that you have and substitute it into the equation. There is no need for you to find a and b. They are not necessary. What is important is c and d. So a and b, we don't find that one. There's no need. We are only interested in c and d, or whatever variable that you produce here. This is the end of this video. This is second order differential equation. You need to go through this very carefully because it's a little tricky. You need to understand it before you will be able to solve questions under this topic. See you in my next video.